Let us begin a new chapter, lenses. Before coming to lenses, first we will study what are spherical mirrors. In our home, a mirror is available. That mirror is known as plane mirror. This is the example of plane mirror. Now plane mirror is a glass, but its one surface is the reflecting surface. Reflecting surface. Then its other side is painted with different chemicals. We can say silver nitrate. With that it is colored. So here we can say that this is the reflecting surface. Here nothing is there. So what they had done, first they had taken one glass piece. On that they coated with silver nitrate. Over that they coated with a paint. Either ash color paint or orange color paint. All they are putting it. Then as a result of it, here we can be able to get 100% of reflection. How we are looking, same to same look we will get. So silver compound they are using for covering it. As a result of it, we can say that 100% of reflection will get. Now we are studying about a spherical mirror. So before that I will say you, mirror itself is of two types. One is known as plane mirror, other one is known as spherical mirror. Now again, spherical mirror, I can say one example like that. Such a way spherical surface will be there. One spherical mirror, spherical surface. Here again we can say that spherical surface. Even inside part we can say spherical surface. Even its inside part we can say that spherical surface. Outside as well as inside spherical surface. Here also inside as well as outside spherical surface. Now speciality, spherical mirrors speciality, that is made with the help of glass. Even plane mirror made with the help of glass. Here now, spherical mirrors itself is of two types. One is known as convex mirror. Other one is known as concave mirror. Now, convex mirror as well as concave mirror. So here now, its a detailed study is not required to you. Even then I will say you. Here convex mirror will be there. Just an example. Such a way this part will be the projected surface. Where the projected surface is there, that is the convex part. Where here depression is there, or we can say that pushed inward we can say. This is the bulged part. This surface is pushed inward. So inner surface is having pit like. So we can say that this is the concave surface. This is the convex surface. Now we can say that which part of the mirror is having shining. Shining means a reflection. So we can say that this surface is having shining. This surface is painted. So we can say that this is the convex mirror. Now suppose inside part, from that a reflection is there. You are able to see your face. But at the same time back side part is, this is inside part reflection is there. Back side part painted. Then we can say that this is an example of concave mirror. But one important thing, convex mirror, concave mirror, plane mirror. That means all types of mirrors are made with the help of glass. Now we will study which all parts are there. That means inside of the mirror has which all parts are there. That we will study. here we can say that a mirror is a mirror. That means a spherical mirror. Now plane mirror already you seen. Spherical mirror is a part of the sphere. Sphere means a glass sphere. Now here we people are cutting. Now just imagine this is the glass bowl. That means inside part will be hollow. Now just imagine this is the glass sphere. Ball means a sphere. Now its central part. This is the center of that sphere. Ball is there, its inside, its center will be there. That center is known as a center of curvature. Center of curvature. Now here through here if we draw a straight line, a line which is passing through the center of curvature, this line is known as principal axis. Principal axis. Now from here towards the curvature if we draw a line, so this line as well as this line which is joining at the curvature, it is known as radius of curvature. Radius of curvature. Now radius of curvature we can represent by putting capital R. Center of curvature we can represent by putting capital C. Now here we are cutting and removing a piece, a spherical piece. That means as and when we cut and remove a part, either this part we can cut and remove, or we can cut and remove like that way this side, or we can cut and remove this part. So which part we are cutting and removing, that part can act as a spherical mirror. Now if we are cutting and removing this side, this part, then the line, we can say that through the center of the curvature, a line which is passing, that is passing through this part of the mirror. So we can say that this point is the pole of the mirror. This point we can say that through the center of the mirror this line is passing. So we can say that this spot, that spot or that point, that is known as pole of the mirror. Now suppose here it is there. This is the mirror. Then so if we are passing a line through the center of this, that means the principal axis, then if you are making like that, then this point will be the pole of the mirror. Through the center of the mirror, which line is passing, but that line's speciality that should even pass through the center of curvature. Then we can say that that can be the, if you are drawing like that way line through the center of curvature, but that should pass through the mirror, then we can say that that point also can be the pole of this mirror. So poles of the different mirror will be different. So here this is the pole, here it can be, if the line is passing like that, then here it can be its pole. If the line is passing, that means the center of curvature, if you are passing through the center of curvature, if the line is passing through the mirror, then through the center of this mirror the line will pass, then we can say that that is the pole of the mirror. So here means I shown only one, that is this is the pole of the mirror. So there are different parts of the mirror. We can say that this is the pole of the mirror. Now radius of the curvature, this is why, because this mirror is the part of this sphere. As a result of it, we can say that this is the center of the curvature because we cut and removed this mirror from this spherical glass ball or spherical glass we can say, or glass sphere we can say. So this mirror is the part of this glass sphere. So we can say that its center of curvature is this. Then radius of the curvature, this also we can say is radius of the curvature. Now one thing else I can say, this is now what will be the focus of the principal focus F. That means the principal focus of the mirror. Principal focus of the mirror is equal to R upon 2. That means what is the radius of the mirror? That we have to divide by 2. So we will get, now this R I am removing from here. This is again we can say a radius of the whole size from center of the curvature towards the curvature we can say. That is a radius here also from the center of curvature towards the curvature of the sphere. We can say radius of the curvature. Now what will be the principal focus of this mirror, that is from curvature towards here radius is there, its half how much is there, that is the principal focus of this mirror. Now we will study in detail about lenses. Now, what are lenses? Lenses are transparent medium. Transparent medium means what? Through that light can be able to pass. It can be, lenses can be able to made with the help of either glass or plastic. Now, lenses are present in cameras, then we can say that in microscopes, then telescopes, binoculars, then spectacles, so cameras are present in various devices we can say. Cameras, inside the camera it is there. Even we can say that inside the microscopes, compound microscope, simple microscope. Then we can say one more example, magnifying glass. In all these things having lenses. Now the specs which we are wearing, especially me, in my spectacle itself, you can find that a glass, but this is actually lens. Now here there are different types of lenses are available. So let us see now what are the different types of lenses. First we can say that lenses are divided into two types. One is known as convex lens, other one is known as concave lens. Now this convex lens itself is of three types. Similarly, concave lens is also of three types. The first one, that is known as biconvex lens, or we can call it as double convex lens. Then other one, that is known as Plano convex lens. The other one is known as positive meniscus lens. Positive meniscus lens. Now, concave lens itself is also of three types. They are biconcave lens, then Plano concave lens, then negative meniscus lens. Now, with the help of diagrams, we will study biconvex lens. That means it's both the surfaces will be like that. Bulged condition will be there. We can say that convex condition. That is, surface will be in bulged condition. Now, as I shown you here, now you see, in case of convex lens, here this part as well as here also such a way will be there. So both the ends, both the surfaces will be bulged. This is known as a bulged part. Similarly, this surface also will be bulged. But it is made, this is now steel. But in case of lens, it is made with the help of a transparent medium. We can say that either glass or plastic. Now we can draw like that way. This is the biconvex lens. Now, Plano convex lens, one surface will be plain, other surface will be bulged. This is known as Plano convex lens. Positive meniscus lens, its speciality is such a way will be there, convex part, then other part will be concave. So we can say that this part will be convex, this part, one side will be convex, one side will be concave. Such a lens will be there. That means it will have two surfaces. Lens speciality, it will have two surfaces. One surface will be bulged, other surface will be like that. Concave will be there. Now, biconvex lens will be there, then both the surfaces will be bulged. Now, Plano convex lens means one surface will be bulged, other surface will be plain. Now we are studying about a concave lens. Concave lens itself is of three types. Biconcave lens. Biconcave lens means both the surfaces are inward, pushed inward we can say. So such a way, one concave surface, this is the other concave surface. Now we can say that this is one concave surface, similarly one more concave surface will be there. After that both the side joined. So here we can say that this is the example of biconcave lens. This is one such a surface, concave surface, this is other concave surface, both of them then joined upside. Then we can say that this is the example of biconcave lens. Now what is Plano concave lens? One surface will be plain, then the other surface will be concave. Then we can say that this is one surface is plain, one surface will be concave. Then we can say that this is the Plano concave lens. Now what is the example for negative meniscus lens? Here one surface will be concave, at the same time other surface will be convex. Such a way it will be there. One surface will be concave, other surface will be convex. So such a lens is known as negative meniscus lens. Now we will study the parts or cross section of the lenses. Now, if we say a convex lens, it has or it is two parts of, or it is a part of one sphere. That means there will be two spheres. Its one part will be a part of one sphere. Its other part will be other part of the sphere. Lenses has two parts. One part from one sphere, other part from other sphere. So here we people are going to study the parts of lenses. Then how it is made, that we are going to study. So here two types of lenses we are studying in general. One is convex lens, other one is concave lens. First we will study how to make a convex lens. So for that we are taking two spheres, both of them are intersecting with each other. So here we can say that this is one sphere, so I am writing here S1. This is other sphere, I am writing as S2. This is the center of this sphere. Just imagine this is the center of this sphere. Center of the sphere I am writing as C. Here also C. This is the part of first sphere, so C1 I am writing. This is the center of curvature of the second sphere. Now we can write here one line I am passing through the center of both the spheres. So this line we can call as principal axis. Now I am drawing a straight line through both the edges of the lens. As a result of it, we will get the central point of the lens. The central point of the lens we can mark as O. Now this central point is known as optical center of the lens. Now this C1 and C2 we can say as center of curvature of the lenses, of the lens. Here sphere is there, its center we are calling it as center of curvature of this lens. Now from the center towards the curvature, if we draw a line from here, if we draw a line, so similarly we can say from this center towards here, from this center towards here, curvature, we can say that that is the radius of curvature of the lens. Now this is S1 sphere, so I am writing here R1 radius, here I am writing R2 radius. So we can say that here R1 comma R2 are the radius of curvature of the lens. So here we studied now optical center of the lens, center of curvature of the lens, radius of the curvature of the lens, then sphere 1, sphere 2. Here we drawn which one? A convex lens. It has two parts. One part of this lens is from this sphere, this side. Now here we can say that this part of the lens or this side of the lens is from this sphere. Now we will study how to make a concave lens. For that again I am drawing two spheres. This is the S1 sphere, this is the S2 sphere, but both of them are not intersecting with each other. Now from here we have to draw a straight connection. From here we have to make a straight connection. So we are going to get one concave lens. Here we have got convex lens. Here we are getting a concave lens. So this is, I am writing as convex lens. Here I am writing concave lens. Now we can say that as here what we had studied, same to same. This is the center of curvature of the lens. This is the center of curvature of the lens. We are drawing a straight line through the center of curvature. So we can say that this is the principal axis of the lens. Axis of the lens. Now here we have to draw again a straight line through the center of this lens. So this is central point we can say as optical center. O. O means optical center of the lens. Again, from here till here, how much length is there? We can say radius of the curvature. From here till here, how much length is there? This again we can say as radius of curvature. This is S1 sphere, its part, then R1. This is the S2 sphere, its part, then I am writing R2 radius. Again, if you are drawing the line from here towards here, from here towards here, these all are counting as radius of the sphere. Here also radius of the sphere. We can say that this sphere, it's this part is the part of this concave lens. Again, we can say this part of the sphere is the part of other part of the concave lens. So we can say that this is one part of the concave lens. This is other part of the concave lens. Both of them are the parts of this and this spheres. What is the importance of optical center of a lens? Let us study that. I am drawing here both the type of lenses. This is the convex lens. Here this is the concave lens. And now this is its optical center. This is its optical center. Now what is the speciality or importance of optical center of a lens? If a ray of light passing through the optical center, this direction, any direction, if a ray of light passing through the optical center, they pass through it without any deviation. There won't have any kind of obstacle, straight it will pass. So without any deviation, in a straight line, the ray which is the incident ray, the ray or the rays of light which is passing through the optical center, that ray will pass without stopping. So we can say that without any deviation, the ray of light which is passing through the optical center will pass. Similarly here also, this is the optical center. Now any ray of light passing through the optical center, that will pass through it without any deviation. D-E-V-I-A-T-I-O-N. Deviation means without any stop, straight line it will pass. There won't have any change in the way of light. So without a deviation means there won't have no change will be in the direction. So we can write no deviation, I can say. Here no deviation, its meaning no change in the direction. So we can say that the ray of light will pass in straight condition without stopping. That is the speciality of optical center of convex lens and concave lens. Now we are going to study about what is principal focus. Again, with the help of convex lens as well as concave lens, we will study what is principal focus of the lens. Now I am taking here a convex lens. Here I am taking a concave lens. Now this is the optical center. This we have to imagine, this is the optical center. Now through the center a line which is passing, that is known as principal axis of the lens. Principal axis of the lens. Here again I am drawing a straight line through the optical center of the lens. So I am writing here as principal axis of the lens. Here I am drawing a straight line through the optical center. Similarly, here also I am drawing a straight line. Dotted condition we have to draw it. This is an imaginary line. Because of that dotted line representation we are doing it. Now I am drawing the ray of light passing through the lens. The line should be up to the center of the lens. Similarly, here also we will make it. Now the other one. We can say that the lines which are, or the rays which are going towards the lens, these rays we can call as incident ray of light. So the rays, this thing I am removing here, straight condition I am drawing here. Now the central line that we can call as principal axis. Now here the speciality we are studying now what is principal focus. For that, here now we have to find out now what is principal focus. So you can see that from here, once the incident ray, the rays of light which is coming from any source, that is going and hitting on this middle part of the lens. After that it is refracting and going and passing through a point. Now similarly you can find that these rays after refraction, we can say that this is the incident ray. Once it is hitting at the central part of the lens, it's a direction changing. So we can say that these rays are known as refracted rays. These rays till the lens, which all rays are moving, to them we can say as incident rays. So here now this is known as refracted ray. Like that way number of rays will be there. So many rays will be there, then we can say as refracted rays. Now similarly this one, it is reached up to the center, again it is passed through here. Again this is passed through here. So where it is joined, that joint we can say as principal focus of this lens. So like that way the rays, the incident ray which is going and hitting on the center of the lens after refraction, after deviation, that means once it is reaching here, then here refraction is occurring. That means its direction is changing. Afterwards it is going and hitting a point on the principal axis. So all the rays are going and hitting on the point. So we can say that all these rays are going and converging. Converging means they are going and joining at a point on the principal axis. So we can say that here all these rays are going and joining at a point on the principal axis. This point we can say as principal focus. F is known as principal focus of this lens. Now they all are going and joining on one spot. So we can say that they are converging, joining. Converging means joining. Now we can say that when rays of light, these rays of light which is coming from any source, they are going and joining at a spot. As a result of it, we can say that this spot we are calling as principal focus, and this lens we can call as converging lens. So we can say that convex lens has got one more name, that is converging lens. Now we are going to study about where the principal focus is forming by using a concave lens. So here now I am drawing a straight line towards the center of the lens. We can say that this is the incident ray. Here difference is there. In this case means these all rays, once it is hitting on the central region of the lens, after that each ray is converging at a spot, we can say, or at a point. But here once this ray is going and hitting on the center of the lens, it diverges, it go in other direction. So here again we can say this is the refracted ray, this is the incident ray. Incident ray means the ray which is going towards the lens. Refracted ray, that means the ray which is going away from the lens. This ray is going towards the lens, this ray is going away from the lens. Now once this refracted ray, now again we can draw from here also such a way, again you can find that, again I will draw. Here also I am drawing an incident ray towards the lens. After refraction it goes in other direction. So we can say that it is going in opposite direction, we can say diverging condition. They are not joining, they are going in different direction. So we can say that this ray is diverging and going, this ray also diverging and going. Now if we will develop them, just we have to develop them backward, we can see. Or if we draw again, just imagine if we draw a line through here, we can say, that means through the principal focus, then we can say that this line will appear straight. If we are joining from here like that way line, then we will feel that it is a straight line. Again, if we are drawing from here towards there, or if we are developing it backward, then also it will join at the point, this point we can say as principal focus. Again we can develop this thing towards here. Then if we are drawing a straight line, then we can find that such a way if we are drawing, it will be a straight line passing through the principal focus. Or if we are drawing a line from here, we can find that it is joining here at the principal focus. In case of concave lens, principal focus will be forming at the same side, but this is the imaginary principal focus, we can say. It is not forming straight. We are just developing the lines, this point, just developing the lines. It is not straight condition forming. Here you see, here this line going and joining at the center of the concave lens. Afterwards it is diverging and going in other direction. Actually they are not, refracted rays are not meeting. Here you see that refracted rays met each other. But here refracted rays are diverging and going. So what we are doing, we are just developing them backward. Now where it is coming and joining. So we can see that these are the imaginary lines. Where it is coming and joining, that is the principal focus of the concave lens. This is the concave lens. So we can say that this spot or this point is the principal focus. F we can say this is the principal focus of the concave lens. Of the concave lens. Now we have to study the rules for drawing ray diagrams. One thing by using convex lens, other one by using concave lens. Now by using convex lens, ray diagrams we have to draw, but before that we must know which are the rules we have to follow for drawing ray diagram by using convex lens. Now we are using convex lens. Here we are going to study rules. There are 3 rules for drawing ray diagram by using convex lens as well as by using concave lens. Now first I am drawing principal axis of the lens. We can say this is the principal axis of the lens. Now this is the optical center O. Now here I am making the central part. We can say this is the imaginary line. Now first rule, the ray, again we can write here, this is also means 1 centimeter or 2 centimeter far from here. That means just approximate value we can take. This I am writing as F1, this I am taking as F2. That means principal focus. Each lens will have 2 principal focus. This is F1, first one. This is F2. Each side has 2 principal focus. F1 to F1 this side F2 to F2. Now here the ray, first rule, the ray which is passing parallel to the principal axis. This is the principal axis. Parallel to the principal axis, other ray. We can say this is the incident ray. Incident ray. So we can say that the ray which is parallel to the principal axis, after refraction, pass through the principal focus of the lens. So here now the ray which is passing through the ray which is parallel to the principal axis of the convex lens, after refraction pass through the principal focus of the lens. We can draw with the help of scale. It should be a straight line. We have to draw it with the help of scale. Now, second thing, this is the first rule. The ray which is parallel to the principal axis after refraction pass through the principal focus of the lens. Second one, the ray, here we can say that one object, anywhere I am keeping the object now. Here I am keeping the object. Rays of light is coming from the object. So this I am writing as object. Object means from where light rays are coming. So here I kept the object. Now we can say candle light, sunlight, any. So here now a candle light I kept here. So we can say that this is the object or a scale or anything we can keep. From that light rays are coming. So here we can say that here now from here ray of light passed, that is parallel to the principal axis. After refraction, once it is reached here, hit here, then refraction is occurring. Refraction means refraction, it's a meaning change in the direction. Change in the direction. Now, so one ray we have got, one rule we studied. Other one, a ray which is passing through the optical center passes through the optical center without, in a straight line without any deviation. So here we can say that the ray which is passing through the optical center passes straight line, passes in a straight line without any deviation. Here we can say that there is no deviation, in straight line it is passing. So this is the second rule, this is the first rule. What is the first rule? The ray which is moving parallel to the principal axis. This is principal axis, this is the ray of light. Both of them are parallel to each other. But once it reaches here, it refracts and it passes through the principal focus. The other ray that is passing through the optical center, it passes straight without any deviation. There will be no refraction. No refraction, nothing is there. It will pass in a straight line. The third law, third rule, that is the ray which is passing through the principal focus. The ray which is passing through the principal focus. This is the third rule. The ray which is passing through the principal focus. After refraction, it moves I'll draw it later. Here it will travel, it will move parallel to the, after refraction it will travel or it will move parallel to the principal axis. So here the ray which is passing through the principal focus, after refraction it travels or it moves parallel to the, these two, parallel to the principal axis. Now why I removed here? Because this line and this line, all the three should join at a point. This also should join at a point, like that. So we can say that this is the principal axis that I'll draw upside, I'll write upside. So we can say this is the principal axis. So here we can see that first rule, the ray which is passing from object towards the lens, once it is hitting at the lens, at the middle region, we can say hitting process is taking place at the middle part. After hitting, what is happening? It refracts. This ray, its direction changes and it passes through the principal focus. This ray, which is passing through the optical center, it passes straight without any deviation. This ray, which is passing through the principal focus, after hitting here or hitting at the center, it travels parallel to the principal axis. These are the three rules we require to learn or we should know for drawing ray diagrams by using convex lens. Now we will study rules for drawing ray diagrams by using concave lens. Here this is now convex lens. Now I am making concave lens. Now this is the principal axis of the lens. This is the central point. We can say that this is the upside. I will make it, or anywhere. Here I am making. This is the principal axis of the lens. Here now. From here, this I am writing as principal focus of the lens. Here again I am writing principal focus of the lens. F1, F2 to F1 to F2. Now, here I am keeping the object. This is the object. Rays are going towards the lens from the object. Now central point I am marking. Now the first rule, the ray which is passing from the object towards the lens, here we can say that the incident ray. This ray is known as incident ray. The ray which is passing parallel to the principal axis. This line is known as principal axis. Why this line is passing through the optical center of the lens. Optical center of the lens. So we can say that this line is known as principal axis of the lens. Now the ray which is passing parallel to the principal axis, after refraction it diverges. It diverges. Again, if we are extending it backward, the same ray, if we are extending backward, like that way, if we are extending backward, where it is coming and joining, that spot we can say as principal focus. So we have to develop it now. Where it is coming and joining, that spot we can say as principal focus of the lens. So here we can say that this will be in straight line. So we can say that from here a straight line formation you can see, such a way. So we can say that here a ray which is parallel to the principal axis of the concave lens, after refraction it diverges. This diverged ray, if we are developing backward, this ray will come and join at the principal focus. This is the first rule for drawing a ray diagram by using concave lens. Now second rule we will study. Same thing only, same to same only study, but here lens is different. Now the ray which is passing through the optical center move without any refraction. Through this optical center, the ray which is coming from the object, it moves through the optical center without any refraction. No change will be there in the direction of this ray. So this point we can say as optical center. So this ray which is passing through the optical center passes through the optical center without any deviation or any refraction. Now we are going to study about the third rule. Here I am drawing the ray which is passing through the principal focus, like that. The ray which is passing through the principal focus. This is the principal focus. The ray which is passing through the principal focus. Once it reaches at the central part of the concave lens, then it travels straight. We can say parallel to the principal focus. So here now you see the ray which is passing through the principal focus, after hitting at the central part of the concave lens, after refraction it passes straight, or we can say parallel to the principal axis. This is the principal axis, this is the refracted ray. We can say this is the refracted ray. This is the straight line traveled. That means here after hitting there is no refraction at all. It is fully traveling straight. Here we can say this is changed its way. Path changed. So we can say that this is known as refracted ray. So here we can study now 3 rules for drawing ray diagram by using concave lens. The first rule, the ray which is passing from the object, after hitting at the center of the lens, there occurs refraction. As a result of it, it diverges. It goes in other direction. Second rule, the ray which is passing through the optical center of the lens moves straight without any refraction or without any deviation. The third rule, the incident ray which is passing through the principal focus, after hitting at the center of the lens, travels or refracts, and here once it is coming and hitting here, there occurs refraction, changes in the direction. After that it travels parallel to the principal axis. Then both of them will be parallel to each other. This thing will be parallel to this line. Thank you.